NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will learn an intuitive and very handy rule: how to decompose a fraction when its numerator is a sum or a difference. This will help you simplify expressions and set up partial fractions later. Here is the core rule. If the numerator is a sum, the whole fraction splits into a sum of two simpler fractions with the same denominator. And if the numerator is a difference, it splits into a difference of two fractions. Think of the numerator x plus 2 as two separate pieces sitting over the same denominator y. Splitting the top bar into two parts, one labeled x and one labeled 2, naturally leads to two separate fractions, x over y and 2 over y, added together. Example A. Decompose x plus 2 over y. We write it as x over y plus 2 over y. Watch the color match the terms from the numerator to each split fraction. This rule is just the distributive property of division across addition in the numerator. Example B. When the denominator is a polynomial, the same idea applies. X plus 1 over x squared plus 1 splits into x over x squared plus 1 over x squared plus 1. Example C. If the numerator is a difference, a minus 5 over b becomes a over b minus 5 over b. Example D. 2b minus 3 over b minus 3 can be split as 2b over b minus 3 over b minus 3. This is a valid decomposition, but be careful. You cannot simply cancel b minus 3 across a plus or minus in the numerator. Cancellation requires a common factor, not just a matching piece of an addition or subtraction. Here is what not to do. Do not cross out b minus 3 between the numerator 2b minus 3 and the denominator b minus 3. That would be incorrect because the numerator is not a single factor times b minus 3. Quick practice. Try to decompose these before I reveal the answers. Here are the decompositions. 3x plus 7 over 5 becomes 3/5 x plus 7/5. m minus 4 over 2m plus 1 becomes m over 2m plus 1 minus 4 over 2m plus 1. And t plus 9 over t minus 2 becomes t over t minus 2 plus 9 over t minus 2. To wrap up, whenever the numerator is a sum or a difference, you can split the fraction into a sum or a difference of simpler fractions with the same denominator. This is especially useful for simplifying algebraic expressions, integrating rational functions later, and setting up partial fractions. Great work! Keep practicing by creating your own examples, and be mindful of not canceling across a sum or difference. Here are the core decomposition patterns we will use. Distinct linear factors split into separate constants over each factor. Repeated linear factors require a separate term for each power. Irreducible quadratics use linear numerators. When repeated, stack those terms up to the repeated power. In this lesson, we will set up partial fraction decompositions without solving for any coefficients. We will focus on recognizing the factor types and writing the correct form. Step 1. Distinct linear factors. Factor the denominator x squared plus 3x minus 18 into x plus 6 times x minus 3. Therefore, the decomposition has the form a over x plus 6 plus b over x minus 3. Step 2. Repeated linear factor. Here we have x minus 1 and x minus 2 squared. For a repeated linear factor, we include one term for each power, a over x minus 1 plus b over x minus 2 plus c over x minus 2 squared. Step 3. A single linear factor squared. The denominator is x plus 3 quantity squared. The decomposition is a over x plus 3 plus b over x plus 3 squared. Step 4. A mix of a linear factor and a quadratic that we will keep as a quadratic. The denominator is x times x squared plus 2x minus 6. We can treat the quadratic as irreducible over the rationals. So the decomposition becomes a over x plus bx plus c over x squared plus 2x minus 6. Step 5. Repeated irreducible quadratic factor. The denominator is x squared plus 2 quantity squared. For each power, we use a linear numerator. Ax plus b over x squared plus 2 plus cx plus d over x squared plus 2 quantity squared. Step 6. 3 distinct linear factors. The denominator is x minus 1 times x plus 3 times x plus 4. So the decomposition is a over x minus 1 plus b over x plus 3 plus c over x plus 4. Example: decompose the rational function 7x plus 1 over the product of x minus 1 and x minus 2. We will solve for constants a and b such that the fraction equals a over x minus 1 plus b over x minus 2. Step 1. Multiply both sides by the common denominator, which is x minus 1 times x minus 2, to clear the fractions. This gives an identity for all x. 7x plus 1 equals a times x minus 2 plus b times x minus 1. Step 2. Pick values of x that simplify the equation. If we let x equal 1, the b term disappears. If we let x equal 2, the a term disappears. Step 3. Substitute a and b into the target form to write the decomposition. Quick check. Combine the right side over the common denominator and confirm the numerator equals 7x plus 1. Summary. For distinct linear factors, write constants over each factor. Clear denominators to get a polynomial identity, and solve for the constants by strategic x values or by equating coefficients. Here are two common patterns to remember. Final answer. The partial fraction decomposition of 7x plus 1 over the product of x minus 1 and x minus 2 is negative 8 over x minus 1 plus 15 over x minus 2. In this lesson, we'll decompose a rational expression into partial fractions. Our example is the fraction 1 over open parenthesis k plus 4 close parenthesis times open parenthesis k plus 6 close parenthesis. We'll find constants a and b so that the expression equals a over k plus 4 plus b over k plus 6. Step 1. Assume a decomposition with unknown constants a and b. We write 1 over open parenthesis k plus 4 close parenthesis times open parenthesis k plus 6 close parenthesis equals a over k plus 4 plus b over k plus 6. We'll color code the factors to see how they cancel later. Step 2. Multiply both sides by open parenthesis k plus 4 close parenthesis times open parenthesis k plus 6 close parenthesis to clear denominators. On the left, that leaves just 1. On the right, the factor k plus 4 cancels with a over k plus 4, and the factor k plus 6 cancels with b over k plus 6. Step 3. Expand and collect like terms. A times k plus 6a plus b times k plus 4b. Group the k terms and the constants. That gives open parenthesis a plus b close parenthesis times k plus open parenthesis 6 a plus 4b close parenthesis. Step 4. Equate coefficients. On the left side we have 1, which means the coefficient for k is 0 and the constant is 1. Therefore, a plus b equals 0 and 6a plus 4b equals 1. Step 5. Solve the system. From a plus b equals 0, we get a equals negative b. Substitute into 6a plus 4b equals 1. 6 times negative b plus 4b equals 1, which is negative 2b equals 1, so b equals negative 1/2. Then a equals 1/2. Step 6. Write the final decomposition and do a quick check. Substitute a equals 1/2 and b equals negative 1/2. The fraction becomes 1/2 times open parenthesis 1 over k plus 4 minus 1 over k plus 6 close parenthesis. If we recombine those two simple fractions, the result is exactly 1 over open parenthesis k plus 4 close parenthesis times open parenthesis k plus 6 close parenthesis. In this lesson, we will decompose a rational expression into partial fractions. Our goal is to write 8x minus 42 over x squared plus 3x minus 18 as a sum of simpler fractions. Step 1. Factor the denominator. The quadratic x squared plus 3x minus 18 factors as open parenthesis x plus 6 close parenthesis times open parenthesis x minus 3 close parenthesis, because 6 times negative 3 is negative 18 and 6 plus negative 3 is 3. Since the denominator factors into two distinct linear terms, we propose constants a and b such that 8x minus 42 over open parenthesis x plus 6 close parenthesis times open parenthesis x minus 3 close parenthesis equals a over x plus 6 plus b over x minus 3. Multiply both sides by open parenthesis x plus 6 close parenthesis times open parenthesis x minus 3 close parenthesis to clear denominators. That gives 8x minus 42 equals a times open parenthesis x minus 3 close parenthesis plus b times open parenthesis x plus 6 close parenthesis. Now expand and collect like terms. equate coefficients of x and the constants to form a simple system. Solve the system. From the first equation, a equals 8 minus b. Substitute into the second equation. 6b minus 3 times open parenthesis 8 minus b close parenthesis equals negative 42. That simplifies to negative 24 plus 9. b equals negative 42. So 9b equals negative 18 and b equals negative 2. Then a equals 8 minus b equals 8 minus negative 2, which is 10. Therefore, the partial fraction decomposition is 10 over x plus 6 minus 2 over x minus 3. We start by assuming the standard form for distinct linear factors. That is, 1 over k times k plus 1 equals a over k plus b over k plus 1. Now, we will clear the denominators by multiplying both sides by k times k plus 1. On the left side, everything cancels to 1. On the right side, k cancels with a over k, and k plus 1 cancels with b over k plus 1. So we get 1 equals a times k plus 1 plus b times k. Next, expand and collect like terms. A times k plus a plus b times k becomes a plus b times k plus a. Since the left side is the constant 1, the coefficient of k on the right must be 0, and the constant term must be 1. This gives the system a plus b equals 0, and a equals 1. Solving, we find a equals 1, and b equals negative 1. Substitute a equals 1, and b equals negative 1 back into our assumed form. We obtain 1 over k times k plus 1 equals 1 over k minus 1 over k plus 1. We will factor the denominator, set up constants a and b, clear denominators, equate coefficients, solve for a and b, and substitute back to get the final result. Step 1. Factor the denominator using the difference of squares. X squared minus 4 factors as left parenthesis x minus 2 right parenthesis times left parenthesis x plus 2 right parenthesis. Step 2. Set up the partial fraction form with constants a and b. 1 over x squared minus 4 equals a over x minus 2 plus b over x plus 2. Step 3. Clear denominators by multiplying both sides by left parenthesis x minus 2 right parenthesis times left parenthesis x plus 2 right parenthesis. That gives 1 equals a times left parenthesis x plus 2 right parenthesis plus b times left parenthesis x minus 2 right parenthesis. Step 4. Expand and group like terms. A times x plus 2 plus b times x minus 2 equals left parenthesis a plus b right parenthesis times x plus 2 a minus 2b. Step 5. Equate coefficients of like powers of x. The coefficient of x on the left is 0, so a plus b equals 0. The constant on the left is 1, so 2a minus 2b equals 1. Step 6. Solve the system. From a plus b equals 0, b equals negative a. Substitute into 2a minus 2b equals 1 to get 4a equals 1. So a equals 1/4. Then b equals negative 1/4. Step 7. Substitute a equals 1/4 and b equals negative 1/4 back into the decomposition. 1 over x squared minus 4 equals 1/4 times left parenthesis 1 over x minus 2 minus 1 over x plus 2 right parenthesis. In this lesson, we will decompose a rational function into partial fractions. Here is our example. We want to decompose the fraction open parenthesis 1 minus x close parenthesis over x squared plus 4x plus 3. Step 1. Factor the denominator. X squared plus 4x plus 3 factors into open parenthesis x plus 1 close parenthesis times open parenthesis x plus 3 close parenthesis. Because the numerator degree is less than the denominator degree, we can set up a partial fraction form, a over x plus 1 plus b over x plus 3. Step 2. Clear denominators by multiplying both sides by open parenthesis x plus 1 close parenthesis times open parenthesis x plus 3 close parenthesis. That gives 1 minus x equals a times open parenthesis x plus 3 close parenthesis plus b times open parenthesis x plus 1 close parenthesis. Step 3. Expand the right side and collect like terms. A times x plus 3 plus b times x plus 1 becomes x times open parenthesis a plus b close parenthesis plus open parenthesis 3 a plus b close parenthesis. Now equate coefficients with 1 minus x on the left The x coefficient is -1, so a plus b equals -1, and the constant is 1, so 3a plus b equals 1. Step 4. Solve the system. Subtract the first equation from the second to get 2a equals 2, so a equals 1. Then substitute back to find b. 1 plus b equals -1, so b equals -2. Step 5. Write the final partial fraction decomposition. The fraction open parenthesis 1 minus x close parenthesis over x squared plus 4x plus 3 equals 1 over x plus 1 minus 2 over x plus 3. Quick check. If we combine 1 over x plus 1 minus 2 over x plus 3, we get open parenthesis x plus 3 minus 2 times open parenthesis x plus 1 close parenthesis over open parenthesis x plus 1 close parenthesis times open parenthesis x plus 3 close parenthesis, which simplifies to 1 minus x over x squared plus 4x plus 3. Works perfectly. Summary. Factor the denominator. Set up a over a linear factor plus b over the other linear factor. Clear denominators, equate coefficients, solve for a and b, and write the result. Our final answer is 1 over x plus 1 minus 2 over x plus 3. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.